Hello everybody, today we will start lesson 10, grouping of lamps and cells. Look in this electric circuit. It consists of two lamps, L1 and L2. L2 is connected next to L1, so we can say that these two lamps are connected in series or are grouped in series. When two or more lamps are connected one next to the other, so they are grouped in series. As we know, the current flows from the positive pole of the dry cell to the negative pole of the dry cell. The symbol of the current is I, capital letter, capital I. This is the current, capital I, flows from the positive pole of the dry cell to the negative pole of the dry cell. The current sent by the dry cell is the same of the current carried by L1 and the current carried by L2. So we can say that I equal I1. I is the current sent by the dry cell. I1 is the current carried by L1 and equal L2, I2. I2 is the current carried by the lamp L2. This law is called law of the uniqueness of current. If the voltage of the first lamp is 3 volts and the voltage of L2 is 4 volts, so the voltage of the dry cell is 7 volts. Why 7? Since 3 plus 4 equals 7. This law is called law of addition of voltage. The symbol of voltage is capital U. U equal U1 plus U2. U is the voltage of the dry cell, equal U1 the voltage across L1 and plus U2 this is the voltage across the lamp L2. If one lamp is burnt out, what happens to the other lamps? If L1 is burnt out, L2 stops glowing. Why? Since the damaged lamp acts as an open switch, and then when L1 is burnt out, it acts as an open switch, and then the circuit becomes an open circuit. That's why L2 stops glowing. So you have to know that any damaged lamp acts as an open switch, and then the circuit becomes open. What is the voltage across a damaged lamp? If L1 is damaged, what is the voltage across it? Since the damaged lamp acts as an open switch, so the voltage across this lamp will be equal to the voltage across an open switch, and then it's equal to the voltage across the dry cell or the power supply. Now we will do an application together. The adjacent diagram represents an electric circuit of two lamps L1 and L2, a dry cell 6 volt that sends a current of 5 milliampere. The voltage across L1 is 4 volts. Part 1. Deduce the voltage across L2. If the voltage of the dry cell is 6 volts and the voltage across L1 is 4 volts, what is the voltage across L2? Here I have to use the law of addition of voltage. U equal U1 plus U2. What I mean by this formula, U or this equation, U is the voltage across the dry cell, U1 the voltage across the lamp L1, and U2 the voltage across the lamp L2. U is 6 volt equal U1 is 4 volt plus U2. I want to calculate U2. So U2 equal 6 minus 4 equal 2 volt. This is the voltage across the lamp L2. Determine the current carried by L1 and by L2. They give the current sent by the dry cell is 500 milliampere. So I equal I1 equal I2. I is the current sent by the dry cell, I1 the current carried by L1, and I2 the current carried by L2. All are equal 500 milliampere. This is the law of uniqueness of current. Part 3. If L1 is damaged. What I mean by damaged? Burnt out. If L1 is burnt out, what will happen to L2? L2 stops glowing. Why? Since a damaged lamp acts as an open switch, and then the circuit becomes open circuit. Part 4. If L1 is damaged, what will the voltmeter indicate? Justify your answer. If you look to the circuit, the voltmeter measures the voltage across L1, and in this case, or in this part, L1 is damaged. So when L1 is damaged, it acts as an open switch, and then the voltmeter will indicate the voltage of an open switch, which is equal to the voltage of the power supply or the dry cell, and then it will indicate 6 volts. And since the common terminal is connected to the negative pole of the dry cell, so the value will be positive value. So the voltmeter indicates 6 volts, since the damaged lamp acts as an open switch.